Preparing for SRE at Netlify interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define and measure reliability for a platform like Netlify? I define reliability through the workflows customers depend on: publishing a site, serving a request, triggering a build, or invoking a function. For each, I choose SLIs such as success rate, latency, and freshness, then set SLOs over a rolling window. An error budget converts those targets into delivery decisions. Teams can ship while budget remains, but prioritize reliability when it is exhausted. I would validate metrics against real user impact, not merely healthy servers. While answering, distinguish availability, latency, correctness, and durability. Discuss user journeys, SLIs, SLOs, error budgets, regional impact, measurement windows, and why reliability must reflect customer experience rather than infrastructure health alone. Question 2. How would you design SLOs and error budgets for Netlify deploys and content delivery? I would separate deploy and delivery objectives because they fail differently. A deploy SLO might measure successful production publishes within a defined time, while delivery measures successful edge requests and latency by region. I would use short and long burn rate alerts so severe incidents page quickly without making normal variation noisy. Error budget policy could pause risky releases or require remediation, but exclude customer-caused configuration errors when measuring platform responsibility. Make sure to cover separate SLIs for deployment completion, propagation, request success, and latency. Explain target selection, multi-window burn rates, budget policies, exclusions, and balancing developer velocity with customer-facing reliability. Question 3. A Netlify edge response is intermittently slow in one region. How would you investigate? I would first confirm the issue using regional latency percentiles, synthetic checks, and real user data, separating cache hits from misses. Then I would compare edge, origin, DNS, network, and dependency timings, looking for a deploy, routing change, or cache invalidation event. Traces and request IDs should connect customer symptoms to backend calls. I would mitigate with traffic shifting or rollback, document findings, and keep stakeholders updated while preserving evidence. In your answer, cover symptom validation, regional segmentation, tracing, CDN and origin metrics, recent changes, cache behavior, dependency latency, controlled experiments, rollback criteria, and communication during investigation. Question 4. What is the difference between monitoring, observability, and alerting? Monitoring tells me whether known indicators are within expected bounds. Alerting turns selected conditions into actions. Observability is broader. It lets me infer internal system behavior from metrics, logs, traces, and sometimes profiles, including unexpected failures. For example, an alert might report elevated publish latency, while traces reveal a slow artifact store dependency. I prefer alerts tied to customer impacting symptoms, supported by rich context for efficient diagnosis. Be sure to mention metrics, logs, traces, profiles, high cardinality context, dashboards, alert thresholds, symptom-based paging, and how observability enables investigation beyond predefined failure conditions. Question 5. How would you build an effective incident response process for a major outage? I would declare the incident early, assign an incident commander, and separate technical investigation from communications and coordination. The team should stabilize first through rollback, traffic reduction, failover, or feature disablement, while preserving logs and timelines. Updates should state impact, scope, actions, and next checkpoint. After recovery, I would verify customer workflows, calculate slow impact, and run a blameless review that produces owned, prioritized corrective actions. Focus on detection, severity classification, incident command, technical and communications roles, mitigation before root cause, status updates, decision logs, escalation, recovery validation, and blameless post-incident learning. Question 6. Describe a safe deployment strategy for a distributed platform. I favor immutable, versioned artifacts promoted through automated checks, followed by a canary in a small region or traffic slice. I monitor error rate, latency, saturation, and business signals against the baseline before expanding gradually. Feature flags decouple deployment from activation, while backward-compatible schemas support mixed versions. If customer-impacting metrics deteriorate, I stop promotion and roll back quickly. The strategy should make failure limited, observable, and reversible. In your answer, discuss immutable artifacts, automated tests, progressive delivery, canaries, health signals, feature flags, rollback versus roll forward, database compatibility, and minimizing blast radius during changes. Question 7. How would you design rollback and disaster recovery for site deployments? I would store immutable, content-addressed build artifacts and keep deployment metadata for every version. Promotion should be an atomic pointer change, allowing a fast rollback without rebuilding. For regional or storage failures, replicated artifacts and configuration backups support disaster recovery. I would define RTO and RPO explicitly, test restoration regularly, and validate real user requests after recovery. Rollback fixes a bad release. It does not replace recovering data that was deleted. Make sure to cover versioned artifacts, atomic promotion, immutable backups, recovery point and time objectives, dependency recovery, regional failure, validation, automation, and the distinction between rollback and restoring lost data. Question 8. How would you troubleshoot a failing build pipeline that affects many Netlify customers? I would first quantify affected accounts, frameworks, regions, and failure signatures, then compare successful and failed builds. Queue depth, worker saturation, image changes, dependency availability, and recent platform releases are key signals. I would stop risky rollout, preserve representative logs, and route new jobs to a known good worker pool if possible. Clear status communication matters. Once mitigated, I would reproduce failures, identify the common trigger, and add regression coverage. Cover blast radius assessment, failure clustering, queue and worker health, dependency changes, reproducibility, customer isolation, rollback, capacity protection, communication, and distinguishing platform faults from project-specific failures. Question 9. What strategies would you use to manage capacity for build infrastructure? I would model build arrivals, durations, queue latency, and concurrency by workload type, then forecast peaks around launches or regional events. Autoscaling should react to queue age and saturation, not CPU alone, while maintaining warm capacity for predictable demand. Per account limits and fair scheduling prevent noisy neighbors. Backpressure should return useful feedback instead of letting queues fail silently. I would optimize cost only after meeting queue latency and completion SLOs. Discuss demand forecasting, queuing theory, concurrency limits, autoscaling signals, priority classes, fairness, warm capacity, noisy neighbor protection, backpressure, and cost reliability trade-offs. Question 10. How would you handle a dependency that becomes slow or unavailable? I start by classifying the dependency call: critical, optional, synchronous, or asynchronous. Critical calls need strict timeouts, bounded retries with jitter, and idempotency. Optional calls may use cached or degraded results. Circuit breakers and bulkheads prevent one dependency from consuming all workers. I would monitor dependency latency and error budgets, communicate ownership clearly, and test failure behavior regularly. Retries are useful only when they do not amplify overload. In your answer, include timeouts, bounded retries, exponential backoff with jitter, circuit breakers, bulkheads, caching, fallbacks, idempotency, dependency SLOs, and avoiding retry storms. Question 11. How would you design rate limiting for a multi-tenant developer platform? I would use token buckets to allow controlled bursts while enforcing a sustainable rate, with limits varying by endpoint cost and account plan. The limiter should identify tenants consistently and use shared state or carefully designed regional quotas when requests cross instances. Responses should include clear retry guidance. I would protect both customer APIs and internal queues, monitor rejected traffic, and provide safe override processes. Limits must preserve fairness without punishing normal deployment bursts. Be sure to cover tenant fairness, endpoint-specific limits, token bucket or leaky bucket algorithms, distributed state, burst handling, response semantics, trusted internal traffic, and avoiding accidental denial of service. Question 12. What does good observability look like for a CDN and edge delivery system? I would combine global and regional views of request success, latency percentiles, cache hit ratio, origin fetches, bandwidth, and purge completion. Dimensions such as POP, provider, protocol, site, and response class help isolate faults, but I would control cardinality and sampling costs. Synthetic requests detect broad regressions, while real user telemetry confirms impact. Traces for cache misses should connect edge handling to origin dependencies, making performance and availability diagnosis practical. Mention request success, latency percentiles, cache hit ratio, origin load, regional and POP segmentation, purge behavior, logs, traces, synthetic probes, cardinality control, and correlation with user experience. Question 13. How would you reduce alert fatigue on an SRE team? I would inventory alerts and ask whether each page requires immediate human action. Pages should generally represent customer impact or imminent slow failure, using multi-window burn rates instead of fragile single thresholds. Related alerts need deduplication and clear ownership, with dashboards and tickets handling lower urgency. Every page should link to a useful runbook. I would review false positives, missed incidents, and responder load regularly, then remove alerts that do not change decisions. Focus on actionable, symptom-based alerts, slow burn rates, severity, deduplication, ownership, runbooks, silence policies, periodic review, and measuring pages per incident rather than maximizing alert coverage. Question 14. Explain how you would apply Terraform or infrastructure as code safely. Infrastructure as code gives me a reviewable, repeatable definition of desired state, but its safety depends on workflow. I would protect remote state, run formatting, validation, security policies, and plans in C, then require review before staged applies. Modules should expose safe defaults without hiding important behavior. Secrets belong in a dedicated secret manager, not state or source control. I would detect drift and test destructive changes with explicit approvals. Discuss declarative state, code review, remote state protection, drift detection, plan validation, modules, policy checks, secrets handling, staged applies, imports, and recovery from partial changes. Question 15. How would you secure secrets and access in an SRE environment? I would grant workloads short-lived identities with narrowly scoped permissions, retrieving secrets from a managed secret store rather than embedding them in repositories or images. Access should be audited, rotated automatically where possible, and separated between deployment, runtime, and emergency roles. Break glass access needs approval and post-use review. I would also redact logs, scan artifacts, and test that failed builds cannot print credentials. Least privilege should be continuously reviewed. Cover least privilege, short-lived credentials, centralized secret management, rotation, workload identity, audit trails, break glass access, separation of duties, and preventing secret exposure in logs or build artifacts. Question 16. A production service is running out of memory after a release. What is your approach? I would correlate the memory trend with deployment versions, traffic, workload composition, and instance restarts. Process and heap metrics, allocation profiles, garbage collection behavior, and container limits help distinguish a leak from legitimate growth. My immediate mitigation could be rollback, reducing traffic, or recycling instances while preserving diagnostic data. Afterward, I would reproduce the workload, fix the leak, add memory regression tests, and keep canaries long enough to expose gradual growth. Mention confirming correlation, heap and process metrics, traffic changes, leak versus workload growth, profiling, rollback, instance recycling, limits, canaries, and permanent regression prevention. Question 17. How would you reason about consistency and idempotency in deployment APIs? Deployment requests may be retried because clients cannot tell whether a timeout occurred before or after the server committed. I would assign an idempotency key or operation identifier, persist its result, and make repeated requests return the same outcome. State transitions should be validated atomically, with optimistic concurrency preventing stale updates. For asynchronous work, the API should expose durable status and reconciliation. This approach tolerates retries without creating duplicate deployments. In your answer, explain retries, duplicate requests, operation identifiers, desired state, optimistic concurrency, atomic transitions, eventual consistency, reconciliation, and user visible status during asynchronous operations. Question 18. How would you test resilience in a distributed platform? I would begin with a hypothesis, such as whether site delivery remains within its SLO when an origin dependency fails. Establishing steady-state metrics lets us detect meaningful change. I would run a controlled experiment against a small tenant or region, inject latency or errors, and verify timeouts, fallback, alerting, and recovery. Experiments need authorization, abort conditions, and communication. Findings should become design changes, runbooks, and repeatable automated resilience tests. Be sure to cover failure hypotheses, dependency and regional faults, controlled blast radius, steady-state metrics, experiments, rollback, game days, production safeguards, and converting discoveries into automated tests. Question 19. Tell me about a time you improved reliability without slowing engineering teams. In one service, frequent manual releases caused avoidable incidents and delayed features. I measured rollback time, change failure rate, and alert volume, then introduced automated checks, canary deployment, feature flags, and a documented rollback command. Engineers retained frequent releases, but changes reached full traffic only after health signals stayed stable. Within a few weeks, failed changes and recovery time decreased materially. The key was using automation and evidence, not adding an approval bottleneck. Prepare a structured example covering baseline data, customer impact, intervention, stakeholder alignment, measurable outcome, trade-offs, automation, and how you preserved delivery speed while reducing operational risk. Question 20. How would you prioritize reliability work at Netlify when the backlog is larger than capacity? I prioritize work using evidence, customer impact, SLO violations, failure probability, blast radius, recovery difficulty, recurring toil, and security exposure. A widespread publishing failure generally outranks a low-impact dashboard improvement. I would quantify expected risk reduction and engineering effort, then align with product through a visible roadmap. Error budget trends provide an objective input, while reversible experiments can validate uncertain investments. The goal is sustainable delivery, not eliminating every theoretical failure. Discuss customer impact, SLO and error budget data, blast radius, probability, toil, security, compliance, dependencies, cost, reversible experiments, and communicating trade-offs transparently with product and engineering leaders. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.